So whereas in the case of wireless network, so in order to have a communication among the devices, so we are making use of, instead of switch, you can see we have taken it as an access point. Okay, so now what happens is the internet service provider, they will communicate with the router. So from the router, so it will go through access point. So you can see here there is a wired connection between the router to access point, and from the router to infrastructure. Okay, so now whereas from the access point to your devices what we are connecting, so there it is only the difference is that is wireless. So if I say that it is a wireless technology, means it is not that the entire technology or the entire network is wireless. No, it is not. Only the end user who is going to use, no, so only that case we are going to call it as a, it is called as a wireless LAN technology. And also your mobile communications. So if we are talking about mobile, so they have given you the mobility for your mobile. So even though it is wireless only, but the entire around 70% of your wireless cellular network which works on the wired technology only. So there is only one, that is there is only one way, or there is only one a scope where you can have a wireless option is between the end user. So you can see when we do the communication or when we do the any phone call, so there will be a wireless communication will establishes from where, from the mobile station to base station. So from the base station it's all about wired only. So from the base station it will go to MSC, from the MSC it will go to the gateway MSC, that is PSTN, it will go. From the PSTN it is also it is a wired connection only. So in wireless connection means, so we need to provide a mobility for the users. So therefore only end users or only the end entity communication will be wireless, whereas the rest of the things will be wired only. So this is very very important when we deal or when we need to know about a wireless LAN technology. Okay, so some of the characteristics of this wireless LAN technology is, the first one is it goes for high amount of attenuation over the network. Why? Because the communication media is air. So since we don't have any control over the air, so therefore the attenuation and the interference and multipath propagations are the main important that is the characteristics of a wireless LAN. So if you have a less attenuation and it's the interference is less, and if you have a less multipath propagation means, then we can say that it is a good wireless LANs. Otherwise we need to do some protocols, or we need to apply some channelization method for the wireless LAN technology, so that all the users can communicate with a reduced attenuation, interference and a multipath propagation methods. So in order to understand, or in order to see the characteristics of this wireless LAN or the quality of the communicating media, so we are going to measure the signal over the air with the use of one of the important parameter, and that parameter we are going to call it as a SNR. So what do you mean by SNR? SNR is nothing but the signal to noise ratio. So what do you mean by signal to noise ratio? It is nothing but the power of the useful power divided by the power which has been generated because of the noise. Okay, so if the SNR, so you can see SNR, it is a ratio of useful power divided by the distorted power, or we can say that the noise power. So if the quality of the signal is more means, then the SNR has to be high. If the quality of the signal, if it is less means, then we can say that it has prone to more error. Why? Because since your useful power, it has been occupied or it has been distorted by more amount of noise, so therefore the amount of extraction from that distorted signal, it will be very less. So therefore, when we try to understand, or when we want to do the characterization of the wireless LAN technology, so we mainly focuses on the one parameter, that is nothing but SNR. So if you have a high SNR means, then we can say that we can easily extract, or the communication purpose whatever we have established, so it can be reached successfully. So if the channel, if conditions are very bad means, then you are going to get a low SNR values. So for the low SNR values, it is very difficult for us to decode the message from such low SNR values. So when you talk about these wireless LAN technologies, so these are the important things what you need to understand and what you need to consider during the design aspects of the wireless LAN technology. Is that clear? because in CSMA CD what? So in CSMA CD, so we can able to detect the collision. Why? Because there will be less number of peoples will be there and there will be wired connection will be there. So from the use of power transmission levels in the CSMA CD technology, we can able to extract or we can able to detect the collision in the case of CSMA CD technology. And moreover, this CSMA CD, since it is connected in a wired fashion, so it requires a more power. Okay, and therefore it is not possible for us to use this CSMA CD technology for the wireless LAN technology. And we will be not, since we don't have any control over the transmission media, that is the air, because it is a wireless what we have taken, and the fidelity for the user it is more. So the moment when he want to transmit the data, he will not bother about what exactly it is there in the channel, and he is not able to measure the characteristics of the channel. Why? Because since it is a air, everyone can able to transmit the power, and you cannot measure the power in the air because there are so many other signals will be integrated. So therefore we cannot able to establish or we cannot make use of the access method, that is CSMA CD, in the case of wireless LAN technology. So therefore what we do is we go for CSMA CA technology. So we cannot able to detect the collision in the CSMA wireless LAN technology. Therefore instead of detecting the collision, it is better to avoid. Okay, it is better to avoid. So therefore we go for a CSMA CA technology. So in CSMA CA technology, what we do is, so before collision occurs, so we will make some prior arrangements, or we will make some prior signaling mechanism. So through the use of proper signaling mechanism, we can able to transfer the data without any collision. Okay, so that we can increase the probability of data transmission rate in the case of CSMA, that is wireless LAN technology. Okay, and one more important the problem what you are going to identify in the case of this wireless LAN technology is, the first we are going to call it as a hidden node problem, and the second one we are going to call it as a exposed node problem. So what do you mean by hidden node problem and what do you mean by exposed node problem? We will see it in the next slide. And the access control, when you want to talk about the access control in the case of wireless LAN technology, so one more important parameter what you are going to consider is the distance. That is nothing but the coverage area of each node we need to measure, because that plays an important role in the case of hidden node problem and a exposed node problem. Because since every node will have a transmission range, so the node or the station to whom it is communicating, whether that communicating device it fall under the transmission range of a transmitter or not, we need to see. If the given node or if the destination node falls under the transmission range of the transmitter, means then we can able to transmit the data with a higher efficiency. Provided if the destination node, if the destination node it falls under two transmission range of the two different node, means then there comes the exposed node problem, or we can say that the hidden node problem. So when we talk about this hidden node problem and exposed node problem, the coverage area of the nodes plays an important role. So the distance what the each node we are going to cover in the entire wireless LAN technology, that has to be understood when you want to design any access control mechanism in the wireless LAN technology. So now you can see here the first I told you, right? So the wireless LAN technology will be exposed with a two important problem. One we are going to call it as a hidden node problem, and one more we are going to call it as a exposed node problem. So you can see in the diagram, so this is the example of hidden node problem. So what do you mean by hidden node problem? You can see here. See, we have considered three stations. So you can see the case one. So first we will go with the case one, and later we can go for the case two. So in the case of case one, you can see here we have three stations: the station A, station B, and station C. And we have see the range of station B. So means what? When any data is been transmitted from station B, it can cover up to this much range. So we have drawn a boundary line for B. So means what? When a B transmit any data, it can be reached only within this boundary. Similarly, we have a station A, C, and this station C are covering boundary we have indicated in the circle manner. Okay, so now you consider a case where the station A is belongs to both the boundaries, or the it belongs to both, that is a station B and also a station C. So now what happens is, so when a station B wants to transmit the data to station A, the station C does not aware about whether the communication is establishing between station A and B or not. Similarly, you consider the station C. So now the station C wants to have a data communication with the station A. So since the B is not fall under station A, when any data has been transmitted from station C will not reach to station B. So therefore what this station B will does is that even though there is a data transmission is happening with the station C to station A, the B might transmit the data. So when B is transmitting the data, at that instant of time, the station A, it is falling under both B and C region. So therefore, it will start receiving the signal from station B, that is the information from B station and information from A station. So there at station A or in this region, there is a possibility of collision will happen. Okay, so and this mechanism or this problem we are going to call it as a hidden node problem. Get a hidden node problem is when two stations are differently falls under different region and they cannot able to communicate directly. In such a cases, in the overlapped region, if some more station is occupied, then if you want to have a common data transmission between that station where it falls under two regions means, then there comes a problem. Okay, so that problem we are going to call it as a hidden node problem. So the station B is not aware of whether the station is transmitting or not, and similarly the station A is not station B is not aware whether the station C is transmitting or not. So if they simultaneously transmit the data, then those simultaneous data will collide in the station A. So there the collision may happen in this type of scenario. So this scenario we are going to call it as a hidden node scenario. So you can see here one more case. So one more case you can see here, both station B and station C are hidden from each other. So they don't know whether station B is there or not for C, and similarly station B don't know whether station C is there or not. So what they will do is, so and they will be knowing that there is a station A. Why? Because this station A is belongs to both station B and station C. Okay, so if the stations within the network or within the geographical area, if they are hidden from some other stations means, then those hidden station will start transmitting to a common node. So when they start transmitting a data to the common node, so these common data will collide at the station A, and there is a possibility of collision will happen across the station A. So this mechanism we are going to call it as a hidden node problem in the case of wireless LAN technology. So when you want to transmit any data over the wireless LAN technology, then you need to take care of this hidden node problem properly so that your communication will take place successfully. Otherwise, whatever the data you are going to transmit, that will be lost because of the IEEE 802 project. It has defined two specifications for the wireless LAN. That is the two types of architecture. So one we are going to call it as a basic service set. So that is one type of architecture which is going to provide. Okay, so in this basic service set, so there are again two divisions is there. One is called as an ad hoc BSS, that is a basic service set, and one more is called as a infrastructure BSS. So in the infrastructure BSS, what we are going to have, so in the infrastructure, the BSS with the access point will be there. That will be the coordinator, whereas in the case of ad hoc BSS, the BSS without an access point will be means the centralized station will not be there. So the station itself, they will communicate it and they will transmit the data. Okay, so this is the one of the basic service set. So in this basic service set, what happens is, whatever the wireless LANs or whatever the nodes are there, no, so they will communicate or they will frame a node, the network, and this network will have the provision to have a communication within that only network only. and the size of this basic service set, it is very limited, and there will be no control over this basic service set. And this is one of the simple IEEE project which has been established in the earliest days of the wireless LAN. Okay, so this is a BSS. We are going to call it as a basic service set. So in this basic service set, the nodes will frame by themselves to make a network, and the size of the network will be very small, and it will be in ad hoc in nature. Means whenever the node want to transmit the data, means they can transmit the data directly to the designated node. Okay, so means what, there is no any centralized access will be there in the BSS service set. So in the BSS service set, that is a basic service set, there are two types of networks will be there. One is the infrastructure BSS and one more is the ad hoc BSS. So in the infrastructure BSS, we will be having an access point to have a coordination for the network activity, whereas in the case of ad hoc BSS, there will be no access point will be there, and the node itself, they need to make some protocols, and they should make some rules and regulations for data transmission, so that that is the collision will not happen in a ad hoc fashion. Okay, so this is one of the simple basic service set what we are going to use as an architecture. So the first architecture, we are going to call it as a basic service set. So you can see here the basic service set in the case of ad hoc manner how it is there, whereas in the case of infrastructure BSS how it is there. In ad hoc manner, we don't have any access point. The node itself will communicate. So therefore we are going to call it as an ad hoc BSS. Whereas in the case of infrastructure BSS, you can see here we have a centralized AP. So this centralized AP will act like a coordinator to have a communication. And then what we studied is, we studied about what is a wireless LAN technology, what are the characteristics of wireless LAN technology, and we studied about two important problem. One is called as a hidden node problem and exposed node problem. So the exposed node problem I have not explained yet. I will explain in the next sections. Okay, and we see about the characteristics of wireless LAN, and we studied about two important architecture of this wireless LAN. So the first architecture what we have studied is BSS. So BSS is nothing but basic service set. In the basic service set, you can see here the nodes will frame a network, and there are two types of BSS networks are there. One we are going to call it as a ad hoc BSS, and one more we are going to call it as a infrastructure BSS. So the ad hoc is, there is no any coordinator will be there in BSS. If it is coordinator is there, means then we are going to call it as a infrastructure BSS, where the access point will have a control on the communication over the devices.